In today's daily dose of math, we have several graphs and we're being asked if they show functions. A simple test for a function is to see if any x value has more than one y value. Any x value having more than one y value means it is not a function. So in this inverse function, none of the x values have more than one y value, so the answer is yes, it is a function. Here's a linear function. None of the x values have more than one y value. Yes. Here's a circle. For instance, the x value here, let's say it's x equals -1, would have two y values because there would be a point right up here that would also have x equals -1. There are two different y values. This is not a function. Here, none of the x values has more than one y value, so it's a function. And here in the horizontal line, none of the x values has more than one y value, so it is a function. So this is a simple test. Now we're being asked, are the inverses of these examples functions? And I'm going to draw the inverses very quickly, taking advantage of the fact that I have drawn with a dotted line the equation y equals x on all of these graphs. The inverse of a function forms a reflection of the original function across the line y equals x. So I just have to draw a reflection. So drawing freehand and not perfectly, the reflection of this inverse function looks the same as the original, and the x values do not have more than one y value, so yes, it is a function. The reflection of this linear would look something like this. None of the x values have more than one y value. Yes, it is a function. The reflection of the circle will be another circle that looks the same, is in the same place. Although I'm not drawing it very well, we're still in the same situation. Any x value I choose in the circle is likely to have more than one y value, one down here and one up there, so no, it is not a function. The reflection of this one is going to look like this. And although it's steeper now, and the x values have y values that are getting closer together, you still don't have any x value that has more than one y value. Yes, this is a function. And finally, we look for the reflection of our horizontal line. The reflection of the horizontal line will be a vertical line. And in this case, every point has the same x value. A single x value has an infinite number of y values. As soon as we realize a single x value has more than one y value, no, it is not a function. The inverse of a horizontal line will never be a function. The horizontal line itself is a function. The inverse of a circle, neither the original nor its inverse will ever be a function. And in the case of the inverse function and these type of linear functions, the inverse and the original are both functions. We just have to remember this little trick that helps us decide if something is a function. We find any x value that we can see has more than one y value, we know the answer is no. If we see it's impossible for an x value to have more than one y value, then yes, it's a function. That's today's daily dose of math. Don't forget to like this video and click subscribe.